In a molecule, atoms do not remain stationary. Atoms either vibrate along the bond or rotate about a bond. If this vibrational or rotational motion of a pair of atoms in a molecule brings about net change in dipole moment, then it produces an alternating electric field. So, for example, the HCl which is shown here, H is smaller, Cl, that is halogen chlorine, is a bigger atom. A pair of electrons in a covalent bond between hydrogen and chlorine here is dragged more by electronegative chlorine, and therefore the chlorine atom gains partial negative charge and hydrogen atom gains partial positive charge. This results in formation of a dipole, and molecule is said to be polar. The magnitude of the dipole moment depends on the magnitude of the charges on two atoms. So, in this case it depends on the charges on hydrogen and chlorine, these atoms which are bound together, and the distance between the centers of the two charges. When atoms vibrate along a bond or rotate about a bond, regular fluctuations in the dipole moment occur. And because of this fluctuating dipole moment, there is production of electric field which propagates in the form of waves. Now frequency of these waves is equal to the natural frequency of vibration or rotation of atoms in a molecule. Only those radiations whose frequency matches with natural vibrational or rotational frequency of a particular bond in a molecule is able to interact with the molecule. So here have you understood? All the bonds of the structure, they have their natural frequency, and now when I am bombarding IR radiations on them, the frequency of this IR radiation has to match with one of the bonds natural frequency, either rotational or vibrational frequency. Then only that bond will be able to absorb the IR radiation, and as soon as this absorption of IR energy happens, we will get a peak in the IR spectrum. So for any molecule to absorb IR radiation and to get its peaks in the IR spectrum, the molecule has to have the dipole moment. That means what? Each pair of atoms which is present in that particular structure, there has to be dipole moment, and the correct wavelength of absorption has to be bombarded onto the molecule so that the IR frequency matches with the rotational or vibrational frequency of the bonds, and whenever there is this matching, that particular bond ka peak will appear in the IR spectrum. If you see these examples of the molecules like oxygen, nitrogen, chlorine, they do not possess the uh, delta positive, delta negative regions, because the extent to which the electrons are being dragged on both the sides, that is same. This is O double bond O. So same intensity of the electron dragging is there. So there is no dipole moment existing here, and therefore such molecules are IR inactive. In this energy level diagram, you can see E0 and E1. E0 is the ground state, E1 is the first excited state. So this is the electronic transition level. So E0 से E1 तक जाने के लिए ज़्यादा एनर्जी लगती है, which can be obtained from the electromagnetic radiation like UV. So UV से कम एनर्जी है IR के पास. So if any electrons or molecules, they are absorbing IR radiations, so using IR radiation they will not get that much energy to move from E0 to E1, so they will take small jumps. Okay, so that in between energy levels are rotational energy levels and vibrational energy levels. You can see here, in between two electronic energy levels there are various vibrational energy levels, and in between vibrational energy levels there are many rotational energy levels. The very important point which is to be noted here is electronic transitions are possible with UV. Like UV has more energy, no? So the electrons can jump from E0 to E1, crossing all the vibrational energy levels and rotational energy levels. But with IR, vibrational and rotational transitions are possible. This means after absorption of IR energy by a particular bond, that bond's rotational frequency will increase or that bond's vibrational frequency will increase, and then only the peak will appear in the IR spectrum. There are two different types of molecular vibrations.